Okay, so welcome to our last video for the notes on rational functions. And in our earlier videos, we completed step 1 to find the wholes of the function, if there were any. Step 2 to find a vertical asymptote. Step 3 to find the zeros or X-intercepts if they exist. Step 4 was to find the Y-intercept if that exists. Then in our last video we looked at step 5, which was to find the horizontal or oblique asymptote. Right, it's either one or the other, and we used polynomial division to do that. So now in this last video we're going to put all those things that we found so far together in order to sketch the graph. And then we're going to use that graph to identify the domain and range of our rational function. So in step number 1 for A, we found that there was a hole at -2, 8/5. Then in steps 2 through 4 for problem A, we found a vertical asymptote at x equals 3, a real 0 at 2, 0, and a y-intercept at 0, 4/3. And then in step 5 for problem A, we found that the horizontal asymptote was at y equals 2. So on the back, we're going to put all that information together in order to sketch this graph. So there's our step 1 result, the hole at -2, 8/5. And so 8/5 is a little more than 1.5. So like 1.6. So we're going to go to -2 and then up to 1.6, and we're going to put a hole in the graph with an open circle. Then we have a vertical asymptote at x equals 3. So remember, we use dashed lines for vertical asymptotes. Okay, and then we have a real 0 at 2, 0. So that's going to be a closed circle for our x-intercept at 2 on the x-axis. 0, 4/3 is the y-intercept. So we're going to go up here a third above 1, and we'll have a closed circle there for the y-intercept. Then we have a horizontal asymptote at y equals 2. So y equals 2 gets a dashed line coming right through there. Okay, and I can see from the shape here that's emerging on the graph that we're going to have a curve coming along this vertical asymptote through those x and y intercepts, jump over the hole, and then coming towards but not crossing the horizontal asymptote. So that would be one part of my hyperbola, but I don't know what's happening up in this region of my graph. So I'm going to need some extra points to guide that part of the graph. So I'm going to go ahead and put in a 4 for my x in my simplified form. So if I put in 4, that's going to be 2 times 4 minus 4 divided by 4 minus 3. That's 8 minus 4 is 4 divided by 1 is 4. So the point 4, 4 right here, right, that's going to be on my graph. Okay, if I put in the point 1 to see where this turn is here, that would be 2 times 1 minus 4 over 1 minus 3, and that'd be -2 over -2 is +1. So then I can see when I drew this, I came down a little bit too low, right? That should be going through 1, 1. Okay, and then if I put in a 5, right, I can pick as many extra points as I want to get the graph as accurate as possible. So if I put in 4 already. If I put in 5 for my x, then that would be 2 times 5 is 10, minus 4 is 6, divided by 5 minus 3, that's 2, and so I would have 5, 3. Okay, and then I can see my curve is going to approach these asymptotes and bend through those anchor points. Okay, so that would be a sketch where I have a hole here at -2 8/5, my vertical and horizontal asymptotes at x equals 3 and y equals 2. Okay, the domain is the x values. So as I'm starting at the left and reading toward the right, okay, my domain is beginning at -infinity. And then I have a hole in the graph here with a point discontinuity at -2. And then a union I pick up at -2 on the other side. And now I'm heading along until I reach an infinite discontinuity at 3. And then a union I pick up on the other side of that infinite discontinuity and head off to positive infinity. And then for the range, that's bottom to top for the y values. So we're starting down here at -infinity, and then we're heading up, 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 and then the first undefined area we come to in the range is at that hole, which the hole has a y value of 8/5. So we break here at 8/5, and we need a union to hop over that hole. So we pick up on the top side of that hole at 8/5 and continue on just a smidge until we reach that horizontal asymptote at +2. Then we jump over the horizontal asymptote, and now we're heading up toward positive infinity. And that would be the domain and range. Okay, now we're going to need some graph paper, or I'm going to use a dry erase board here in order to graph our problem B that we've been following through the notes. So in step number 1, we found that problem B had a hole at 3, 0. So here's my origin. I'm going to go over to 1, 2, 3 and an open circle there for my hole. Okay, then step 2 was to find the vertical asymptote, and for problem B that was x equals -3. So back to the origin, and -1, -2, here's -3, and I'm going to use a dashed line for the vertical asymptote at x equals -3. Okay, then step number 3 was to find any real zeros, which would be X-intercepts. We discarded the 3, 0 because that's already a hole, it's undefined there, but we do have a real zero at -4, 0. So 1, 2, 3, there's -4, so that'll be a closed circle. Okay, then we have a y-intercept of 0, -4. So back to the origin and down 1, 2, 3, 4, and there's a closed circle for the y-intercept. Okay, then in step number 5, we found that problem B had an oblique or slant asymptote at y equals x minus 2. So that's linear, that's a diagonal line. So we're going to come down -2, there's my y-intercept. The slope is 1, so this would be the diagonal line that makes my oblique asymptote. Oblique just means slant. And that would be the slant or oblique asymptote. So I've got a good bit of information here on the graph, but it would be a good idea for us to pick some extra test points to figure out, for example, on this side where this bend is occurring, or on this side, right, how far down we need to come for the bend there. So I'm going to put in some values for extra points. So if I used -2, right, that should tell me where this turn is. So I put in -2 for my x, and the equation that I'm using is x squared plus x minus 12 in the numerator. So that'd be -2 squared plus -2 minus 12, all divided by -2 plus 3. And that's going to be, let's see, 4 and minus 2 minus 12 over 1 would be negative 10. So negative 2 comma negative 10 would be a point on this graph. So I go to negative 2 and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which puts my point right here. And then I can follow that oblique asymptote past the hole, and then I'm bending towards my vertical asymptote. Okay, now on the other side of that oblique and vertical asymptote, I've already got a point here at negative 4. So let's scoot over a couple spots and try negative 6, for example. So if we do a negative 6 for the x, and we want to find the y that goes with it, so that's negative 6 squared plus a negative 6 minus 12, all divided by negative 6 plus 3. And that'd be 36, minus 6 is 30, minus 12, and then divided by negative 3 is negative 6. So negative 6 comma negative 6 is on the graph. So this was negative 4, negative 5, negative 6. And then down 1, 2, 3, 4, 5, 6. Okay, and then we follow along the asymptote, bend through those guide points, and that would be a sketch of the rational function for problem B. Okay, so now we want to identify the domain and the range for example B. And for the domain, we're going from left to right. So starting at negative infinity in the x direction, we come along here, and this is going forever down and to the left. So we're at negative infinity, and we keep going until the first undefined area in our graph is this vertical asymptote at negative 3. So we'll have to break the domain at negative 3 with a union, pick back up on the other side of that vertical asymptote, and then we keep going until we reach this hole, and that hole has an x coordinate of positive 3. So we have to stop at 3, hop over that hole, and then head off to positive infinity. Okay, the range is bottom to top in the y values, and we're starting down here at negative infinity. On this piece of the hyperbola, as we come along, we reach a hole here where y is 0, but as you look across, the other piece of the hyperbola is defined where y equals 0. So that closed circle fills in that hole, and we keep going all the way up to positive infinity, so the range is fully unbounded, all real numbers. Okay, and that brings us to the secret question for this lesson. You're going to start with this rational function. The numerator is x cubed plus 3x squared minus 4. The denominator is x squared plus 2x minus 3. And you're going to take this rational function through all 7 steps from our notes. Step 1, find the coordinate of the holes, if any. Step number 2 is to find the equation of the vertical asymptotes. Then step 3, find the coordinates of any zeros. Step number 4, find the coordinate of the y-intercept. Step number 5 is to determine the equation of the horizontal or oblique asymptote. Then step number 6 is to sketch the graph, and to do that you're going to also need to find the coordinate of an extra point where the x is negative 4, and that point will be a relative maximum on your graph. And then step number 7, once it's graphed, you're going to identify the domain and the range. Okay, so make sure that you've got all of that information written down. and then you're going to upload that as your last page of your notes when you upload to Schoology.